Hello students, welcome to my YouTube channel. In this video lecture, I am going to answer important questions of DME from Keith Williams' Radio Navigation book. So far I have answered 60 questions. In this video lecture, I will be answering the next 10 questions. So let's start. Question number 61. The time from the transmission of a DME interrogation pulse to the receipt of the reply from the DME ground station is 1000 microseconds. What is the slant range? The formula is slant range is equal to speed of light into time divided by 2. Time interval is 1000 microsecond. It is inclusive of 50 microseconds. So actual time taken for the signal to go and come back will be 1000 minus 50, that is 950 microseconds. So range will be speed into time divided by 2. So range will be 10 raised to 2 into 1.5 into 950. So range will be equal to 1.5 into 950, 1425 into 10 raised to 2 meter. So range will be 142.5 kilometer. 142.5 divided by 1.85 is 77 nautical miles. So correct answer here is land range is 77 nautical miles. Next, height is given. DME range. DME range means land range is given. What is true range or actual horizontal ground range? So this is your triangle. Now the height of aircraft is 32,000. 32,000 is nothing but 5.3 nautical miles. DME range is how much? It is 16. Now we have to find horizontal ground range. So this is a Pythagoras theorem. Let's apply the formula. 16 square is equal to 5.3 square plus x square. So x square is 256 minus 5.3 square, 2809. So just consider 28. 28.09, consider 28. 256 minus 28 is equal to 228. So x will be equal to square root of that, 15 nautical miles. 15 nautical miles. So this x is 15 nautical miles. The design requirements for DME stipulate that at a range of 100 miles, maximum systematic error should not exceed what? So the error should not exceed plus minus 0.25 nautical miles plus 1.25 percentage of the range given in the question. So that means plus minus 0.25 miles plus 1.25 percentage of 100. Okay. So that is plus 0.25 plus 1.25, that is 1.5 nautical miles. The correct answer here will be option Charlie, plus minus 1.5 miles. 64. DME is given, aircraft ka height is given, what is the ground range? Now here you have to remember the elevation of beacon is 167 foot. So that means, let's say this is your ground. Beacon is 167 feet above that. Aircraft is 43,000 feet above. That means just above the DME it is how much high? 43,000 minus 167, 42,833. Now that is equal to how many nautical miles? 7.138. So approximately 7 nautical miles. So I will draw a triangle here. This is 7.1 or 7 nautical miles, and DME is 15. We have to find out this ground range. So 15 square is 7 square plus x square. So x square is 225 minus 49. So 225 minus 49 is 176. So x will be root of 176, 13.266. Okay, so approximately 13 nautical miles. So this is the answer. Again, aircraft is at 36,000 feet, 10 nautical miles ground range. What is the DME range? What is the slant range? So draw a triangle. This is 36,000, 6 nautical miles. This is 10 nautical miles. What is the slant range? So slant range will be equal to x square, 6 square plus 10 square. So 36 plus 100, that is 136. So x will be square root of 136, that is 11.6 nautical miles. So slant range is this much. 66. En route, DME and VOR that have the same Morse code identification are associated and are within 600 feet of each other, 100 feet of each other, always co-located, okay, within 2000 feet of each other. So they are talking about en route, okay. So there are three ways in which DME and VOR can share the same Morse code identification. First, if they are co-located. Second, if they are serving or giving its services for a terminal area, terminal airspace, and when it is providing its services in terminal airspace, the maximum distance between them must be 30 meter or 100 feet. But now the question says it's en route airspace. So en route is not terminal. En route airspace is beyond terminal airspace. So first we have airport aerodrome traffic zone, then we have terminal area, then we have en route or area control. So the maximum distance between both transmitters in en route phase of the flight or that airspace which is called en route airspace or area. Okay, so in that case the transmitter the maximum separation between those transmitters is 600 meter or 2000 feet. So the correct answer here is delta. En route DME and VOR are associated and are within 2000 feet of each other. Okay, this is wrong. It should be 600 meter, not 600 feet, and 600 meter translates to 2000 feet. Charlie is wrong because it states always. Maybe the DME and VOR are separated by some distance. Bravo is wrong. It is 100 meter. It is correction. It is 30 meter or 100 feet. Okay, if they are serving the terminal area. Next, which of the following provides distance information? Very easy. DME. VOR provides bearing information, the radial you are situated on. ADF provides relative bearing information. VDF, very high frequency direction finding. Again, that will be able to, this facility can be used to again get bearing and track your aircraft towards the station. We call it magnetic bearing to the station, or track it away from the station. We call it magnetic bearing away from the station, QDR. So the DME is the only instrument of this four which is capable of giving range or distance information. 68. Airborne DME equipment will transmit pulse pairs at a comparatively high PRF when. So very important, there are different modes of this DME airborne receiver. First is the search mode. In the search mode, it will search for a nearby DME station, a proper DME station. Okay, if it successfully searches for that DME station, it will reduce its search rate or scan rate to to a particular value. I will give that value. And so in case of search mode, it is 150 pulse pairs per second as given in the question. Okay, the DME interrogator transmits 150 pulse per second for 100 seconds. That means in total 100 seconds it will have transmitted 15,000 pulse pairs. In this 100 seconds, if it is unable to achieve a lock on or have a successful connection between itself and the ground DME station, it will reduce or it will decrease the scan rate from 150 pulse pair per second to 60 pulse pair per second like given here. And once after that, so this is 60 pulse per second. Okay, if lock on is not achieved, and when lock on is achieved successfully, will reduce the pulse pairs to 25 pulse pair per second. Okay, as given in the question, 25 to 30 pulse pairs per second. Okay, so during the range search, the range counters or pointer of the indicator, that means the DME indicator or the DME equipment in the cockpit, those range counters, the position or the place where they show the range information, rotate rapidly from 0 to maximum range. Maximum range of a DME is normally 200 miles. It can be more. This takes 4 to 5 seconds in modern equipment, 25 to 30 seconds in old systems. If no response is achieved in that period, the pointer or counters return rapidly back to 0 and the search starts again. So the correct option here is when the DME equipment, when is the time or at what point of time will it transmit pulse pairs at high PRF, means high pulse repetition frequency. So frequency is maximum in case of search mode, 150 pulses per second. So when first switched on and after channel change, yes. At all times, no. When the distance is above 50, no. Whenever a stable signal is being received, no. So option A is the correct option. When is VOR and DME station associated? So similar to the previous question, they are said to be associated when they are co-located. If they are serving the terminal airspace, they must be within 100 feet of each other. If the outside terminal airspace, they must be at maximum 2000 feet within each other. So the correct option here is the aerials will be mounted on top of each other. Wrong. Their identifications will be identical in all respects. No. They may be separated by as much as 600 meters. If they are meant for en route navigation, yes, 600 meters is 2000 feet. Their signals must be tuned in by VOR and DME sets having common frequency control. Wrong. So Charlie is the correct option. 70. A DME is operated in the search mode. Search for lock means search mode, which is true. The pulse recurrence frequency becomes maximum and the range counters count up to the maximum value. The pulse recurrence frequency increases and the range counters count down from the maximum and the power decreases. PRF decreases and the range counters count down from maximum and power increases. PRF increases and the power is increased. So the correct option here is your pulse repetition frequency. In search mode, the pulse repetition frequency is maximum 150 pulse pair per second. So the correct option here will be option A, and the range counters count up to the maximum value as given here. The range counters, okay, rotate rapidly from 0 to the maximum. So the correct answer here will be option alpha. PRF becomes maximum and the range counters also count up to the maximum value. Here PRF decreases wrong. PRF when it around to so option A. So this concludes our lecture. I hope you have understood all the 10 questions, the answers, explanations. Keep practicing all these questions again and again till you get confident in them. Practice many questions from Oxford and RK Bari also. I have already uploaded those questions, so do watch that lectures also. Subscribe to this channel if you haven't yet. Share this video with your friends and hit the like button if you have liked this video lecture. Thank you for your time.